My path to urban design and planning was anything but a straight line. Initially trained as a social scientist, the way humans perceive the built environment and how the intentional design of those environments impacts human behavior and health is what drew me to pursue an advanced degree in landscape architecture and environmental planning. During my first semester in grad school, I was asked to illustrate an image of my personal landscape, or ecology. For me, it was about relationships, and I didn't think twice about humans being at the core of my vision. When presentation day came and my landscape was pinned up next to my classmates' landscapes, I saw mostly rivers, trees, and vistas. I became worried I had misunderstood the assignment. However, I learned over my degree program to follow my gut because humans are an inherent part of the landscape. The woman in the bottom left corner is my grandmother, my Nana. Her love of gardening, her endless fascination with creating environments of wonder and excitement for all those in her life, and her obsessive attention to detail significantly influenced me throughout my life and inspired me to pursue a career in design and planning. She had a very important role in shaping the person I am today. She died on July 4th, 2021, after a 7-year battle with dementia. Dementia is an umbrella term used to describe brain disorders characterized by cognitive decline, behavior changes, and the ability to perform everyday tasks. The most common type is Alzheimer's disease. With a foreseen exponential rise of Alzheimer's cases by 2060, there is an increased need to search for point source dementogens, or categories of toxins that can lead to dementia. However, there is little research on mitigating environmental pollutants related to dementia with landscape-based solutions. Today, I'd like to talk briefly about my research as a graduate student titled Toxic, Tonic, Mapping Point Source Dementogens and Testing the Ability of Environmental Tonics to Mitigate Public Health Concerns. I started my research with a goal of better understanding how human, plant, and animal health is intertwined, and how the environments we build impact our collective health. I began mapping potential point source causes of contamination and watershed boundaries at the national scale to see if there was a relationship between where toxins were concentrated and where there were high rates of human health concerns, such as dementia. One environmental toxin I suspected to be a contributor to the rise in dementia cases was coal ash ponds. These ponds are unlined holes in the ground where a viscous slag-based cocktail of mercury, arsenic, cadmium, and many other toxic heavy metals are continuously dumped. These heavy metals are also considered dementogens, or toxins that can cause dementia. I use Geographic Information Systems, GIS, mapping to look for patterns in the built and social environment related to where the cases were occurring at above average rates. I observed that dementia rates were disproportionately higher in Black and Latin American communities. Further, older Black Americans are twice as likely to develop dementia as older white Americans. I began to ask myself questions such as, is there an association between disproportionate rates of dementia in communities of color and the presence of coal ash ponds? And can landscape-based strategies such as constructed wetlands be used to mitigate dementogens? These ponds are adjacent to major water bodies and susceptible to dam breaches and seeping into the groundwater. When this happens, we see devastating impacts on aquatic and human life. Rural communities often rely on well water and can lack the resources to demand testing from potential polluters. In Rock Hill, South Carolina, and Union County, North Carolina, we see continuously elevated rates of dementia-related deaths year after year after year. These locations are downstream from the second most contaminated coal ash site in the entire U.S. I use map-based visual storytelling as a strategy to demonstrate complex sociotemporal problems in the built environment, particularly in areas in proximity to the Allen Steam Station coal power plant near these locations. By layering social trends related to race and cognitive decline on top of the toxic infrastructures in the built environment, this North Carolina case study revealed the burden of coal ash is much heavier in communities of color. A consistently high number of people dying of the same disease in areas downstream from one of the most contaminated coal ash sites in the nation may suggest that some land use characteristics play a role in the pervasiveness of the disease. By mapping the human experience of coal ash phenomena near Charlotte, North Carolina, we revealed an association between disproportionate rates of exposure and elevated rates of dementia in communities of color in the presence of coal-powered plants. In this case study, I observed that counties with coal ash ponds within a 5-mile radius of a community of color were also counties that had a high concentration of dementia cases. To address this wicked problem, a theory emerged that landscape-based strategies such as constructed or human-designed wetlands could be used to mitigate environmental dementogens related to coal ash and alleviate this social justice issue with an environmental tonic. Constructed wetlands and strategies that use plants to clean up toxic environments are well-documented solutions known to play a powerful role in mitigating contamination. In the second phase of my research, I tested these theories with a physical model to test the impacts of using landscape-based solutions as environmental tonics. The model simulation demonstrated the constructed wetland would capture and trap most of the dementogens on site, theoretically diminishing the negative impacts of the built environment on surrounding communities' health. So, where do we go from here? How do we use what we've learned so far? For one thing, we need designers, planners, policymakers, and industrial companies to work together to apply landscape-based methods and design interventions to other environmental toxins. We also need to investigate whether these methods and interventions will work with dementogens that are produced from other sources, such as traffic pollution. There's still a lot of work to do, but research like this is making progress on this wicked problem. The practice of landscape architecture includes keeping the public safe from hazards, protecting natural resources, sustainably managing the natural and built environment, and enhancing social, economic, cultural, and physical functioning, now and in the future. The methods of abstract mapping, data visualization, and prototyping solutions with models can emphasize the unjust implications of the built environment on non-communicable diseases and emphasize the need to make the public realm more resilient against environmental toxins for all people.